So hey guys, welcome to our YouTube channel. This is the second video of Astrophysics and Astronomy playlist. So in this video we are going to cover time scales, brightness, apparent magnitude and absolute magnitude. So we will follow the CBCS syllabus. So let's start. So let's discuss the time scale in which our universe works. So astronomy works between a broader time range. The present age of our sun is about 5 billion years and it is estimated that it will live another 5 billion years in its current form. Also, the age of our galaxy is about 10 billion years, and various estimates of the age of the universe itself gives a figure between 12 to 16 billion years. Current age of our universe is near about 12 to 16 billion years. And on the other hand, if the pressure inside a star fails to balance the gravity, then the entire star may collapse in a time which can be measured in seconds. That is the supernova explosion, which can be measured in seconds. Yeah, so there are various processes in our universe which requires time of the order of second, and also there are various phenomena which occurs in billion of years in our universe. So our universe, the range in which our universe works, is a fraction of second to a billion of years. So now let's discuss about brightness. So when you observe a street lamp closely, it appears bright to us. But when the same street lamp is observed by us from a distance, then the same street light appears faint. On the same way, a star might look bright because it is closer to us, and a really brighter star might appear faint because it is too far. So we should consider the distance of stars from us in obtaining their brightness. That is, so we should be aware of the distance of star from us whenever we try to obtain their brightness. So here you can see that there are two stars, star 1 and star 2. Star 1 is closer to the observer as compared to star 2. So star 1 appears bright to the observer as compared to star 2. But this does not mean that star 2 is brighter than star 1 is brighter than star 2. Star 2 may be brighter than star 1, but as it is situated far from star 2, so it appears faint. So this doesn't imply that star 2 is fainter than star 1. So this is just apparent brightness. But apparent by it means that how bright it appears from Earth. So it depends on the distance between the stars and the observer. So the apparent brightness of a star is defined in terms of apparent magnitude of a star. That is how bright it appears from the Earth. You can write this definition as the definition of apparent brightness. So let's discuss what is apparent magnitude. So apparent magnitude, denoted by m, of an astronomical object is a measure of how bright it appears from Earth. So according to magnitude scales, a small magnitude means a brighter star. On magnitude scales, apparent magnitude m equal to 1 means the brightest star. That is, a star which has m equal to 1 is the brightest of all other stars. And m equal to 6 means the least bright star. That is, the star which is apparent magnitude equal to 6 is the faintest star in our sky. So the brightness of a star with apparent magnitude follows the order. The star with apparent magnitude m equal to 1 is brighter than 2, which is brighter than m equal to 3, then 4, then 5 and 6. So the relation between brightness and apparent magnitude is given. So m1 minus m2 equal to 2.5 log base 10 b2 by b1, where b2 is the brightness of a star, say star 2, and b1 is the brightness of, say, star 1. So simplifying this, we get b1 by b2 equal to 100 raised to the power m1 minus m2 by 5. So where b1 is and b2 is the brightness of star 1 and star. So this star 1 and star 2. So this is basically a relation between the brightness of a star and their apparent magnitude. But now we have discovered many astronomical objects which are brighter than m equal to 1 and fainter than m equal to 6. So now negative numbers and number greater than 6 are introduced on the magnitude scale. So the larger magnitude on negative scale indicate the higher brightness, while the larger positive magnitude indicates the faintness of a star. That is, a star which has large negative number, that is larger magnitude of negative scale, is the brightest star, and which has the largest positive number in the magnitude scale is the faintest star. So this is a modern magnitude scale. So here you can see that if we go on the left side, that is on negative numbers, the brightness of the objects increases, and if we go to the right side of the negative magnitude scales, their brightness decreases. So here you can see that Venus is brighter than Sirius, and full moon is brighter than Venus, and sun, which appears to be the brightest astronomical objects in our sky. And if we go to the right side of the magnitude scale, their brightness decreases. So here you can see the Hubble telescope, which was the most powerful space telescope sent by NASA, and now it is replaced by James Webb telescope. Is a very fainter object in our sky. So this is for today's video. Thank you for watching this. So you can download notes from the link given in the description box. And if you have any requirements, doubts, you can please comment below. So please like and share this video and subscribe to our channel. Thank you.